Hello everyone, hope you are doing good. Myself Kasturi, working as an assistant professor in the Department of Artificial Intelligence and Data Science, SNS College of Technology. So in this video, we are going to see about the basic electrical elements. So this topic introduces the most fundamental concepts of electrical engineering. So every electrical system, whether it is a fan, mobile charger, electric vehicle, computer or AI hardware, was based on these four quantities, that is voltage, current, power and energy. Before analyzing circuits or learning electronics, these basics must be clearly understood. So real-time example, when you plug in a mobile charger, electricity flows from the socket, gets controlled inside the charger and charges the phone battery. So this entire process is governed by voltage, current, power and energy. So this slide shows the learning roadmap. First we understand what electricity is, then we study voltage, current and resistance, followed by the nature of current AC and DC, and finally the basics of electric circuits. So as a real-time example, just like learning to drive, first knowing the vehicle parts, then learning how to control speed and brake. Here we first learn basic electrical quantities before circuit is analyzed. So electricity comes from. Electricity is not created magically. It is generated from energy sources like power plants, hydro, or thermal or nuclear, and through generators, diesel generators or petrol generators, and solar panels and windmills, batteries, vehicles or alternators, natural phenomena like lightning. Okay, so these are all the sources of electricity. As a real-time example, electricity at home comes from hydro or thermal power plants. Solar calculators and street lights use solar energy. Car headlights work using electricity generated by the car alternator. And mobile phones run on battery power. Voltage. So voltage is the electrical pressure that pushes electrons through a circuit. It is measured in volts. Voltage represents the potential difference between 2 points. Water analogy. Voltage is like water pressure. Without pressure, water will not flow through pipes. As a real-time example, a 1.5 volt battery powers a torch. A 230 volt AC power supply powers the home appliances. A mobile charger reduces 230 volt AC to 5 volt to safely charge the phone. Current. So current is the flow of electrical charge through a conductor. It is measured in amperes. Current indicates how much electricity is flowing. Water analogy. So current is like the amount of water flowing through the pipe per second. Okay. So as a real-time example, take an LED bulb. An LED bulb requires a very small current. An electric heater or motor requires large current. So thin wires carry small current. Thick cables carry large current. Resistance. So resistance is the opposition to the flow of current, measured in ohms. Every electrical component and material offers resistance. As a real-time example, nitron wire in heaters have high resistance producing heat. Copper wires have low resistance allowing easy current flow. Fan regulators control resistance to vary the speed. So practical meaning, a resistance protects devices from excessive current. So these are all the units abbreviated here. And nature of current. We are having AC and DC. So there are two types of currents. AC is nothing but alternating current. It changes direction periodically, and DC current, direct current, flows in only one direction. So most systems today use both AC and DC. So real-time example, home power supply is an AC in nature, and mobile phone battery is DC in nature, and laptop AC input, DC internal operation. DC current. So DC current remains constant with time and is widely used in electronics and embedded systems. For example, mobile phones, laptops, power banks, electric vehicles that is battery powered, and IoT sensors and microcontrollers mainly used. And the main point is a battery store DC power, and inverters convert DC into AC for home use. AC current. So AC current is easy to generate, transmit and distribute over long distances. Transformers allow voltage level changes, reducing power loss. As an example, fans, lights, refrigerators, washing machines, and industrial motors, machineries, and electric railway systems. These are all use AC. So high voltage AC reduces current, minimizing transmission losses. The next comes is the power. So electrical power is the rate at which electrical energy is consumed or converted. So power P equal to voltage V into current I. Okay. So measured in watts. For example, 60 watts bulb consumes less power than 1000-watt heater. Air conditioners consume high power and low power IoT devices consume only milliwatts. Okay. So energy. Energy is the total electrical work done over time. It is measured in joules or kilowatt hour. Energy equal to power into time. Okay. So as a real-time example, electricity bills are based on units kilowatt hour. A 1 kilowatt heater used for 1 hour equal to 1 unit. Battery capacity is measured in watt henry or watt millihenry. So thank you. So with this, I will conclude. So this conclusions the introduction of voltage, current, power, and energy, the building blocks of DC circuits and electrical systems. Thank you for the patient learning.